So those last several video segments were about our first interpretation of the definite integral, namely as an area, whether the area between two curves or the area under a curve between the curve and the x-axis. Another interpretation that we've already seen is if we've got a rate of change, this is in fact what motivated us to get concerned with finding areas in the first place, right? Some of you might have been motivated just as a pure mathematical interest that you didn't know how to find the area under a parabola or under a sine curve, and you thought that was cool. That's definitely the way it goes for me, and that's great. Other people might be motivated by a more practical sense. As we said, if you have the rate of change of a population, then to find the actual amount of people that were added or lost, you need to find the area under that curve. So this is our second interpretation. It's called total change or net change. Those are synonymous in my world. The rate of change of the amount of water in a tank on the interval from 0 to 4 is given by this function, f of t equals 9 minus t squared liters per hour. I'm really going to try to say liters and not gallons this time. Liters per hour. What's the net or total change in this amount on the interval from 0 to 4? Now I've drawn this graph. We don't need the graph to do the problem, but this will just help us understand. This is the graph of the rate of change. So for the first, when does this cross the x-axis? T-axis, if we set this to 0, that should cross at 3, right? So this area here represents what? At this time, the rate of change was positive. So this represents the net gain in the amount of water during the first 3 hours. Now, the rate of change became negative, right? Remember, this is the graph of the rate of change, not the graph of the amount of water. This is like we did way, way back where we looked at the graph of the derivative and tried to understand what that told us about the actual quantity. So this area here represents the amount of water that was lost during the final 1 hour. And if I've drawn this graph accurately, what sort of answer do you expect for the total net change, positive or negative? It certainly seems like more water was gained than water was lost here. So the change in the amount on this interval, we don't need to worry about drawing rectangles or anything like that because we have the fundamental theorem of calculus. It says the change in the amount, we just need to integrate from 0 to 4, our function, 9 minus t squared dt. Let's just pause for a second to understand how incredible this integral in the fundamental theorem is. It's taking account of everything that happens between time 0 and time 4. It's taking account of the positives. It's taking account of when it touches the axis. It's taking account of the negatives. All of that, all in one go. We don't have to worry about any of it because the fundamental theorem does that all for us. And all the fundamental theorem asks of us is a very little bit. It says, can you find me a function whose derivative is 9 minus t squared? So if you can do that for the fundamental theorem, it will do the rest. 9t minus t cubed over 3. Well, okay, it's going to ask us to do a little bit more. Once we found that antiderivative, it's going to say, can you successfully plug in two numbers, and can you successfully subtract? And if you can do that, you get the right answer. So first we plug in the 4. So 9 times 4 minus 4 cubed over 3. And then we get a break when we plug in the 0. Everything is 0. So this is 36 minus 64 over 3. If we get a common denominator, that's 108 over 3 minus 64 over 3. 44 over 3. Is that what I got? Sure is. 44/3 liters. So during this time, we gained 44/3 of a liter, or what, a little bit under 15 liters of water into the tank. So the amount that came in was more than the amount that came out by about 15 liters. And this works for any sort of function that you would like, right? Any sort of rate of change, this is going to give us the method. This is the method to find the total change. And I think we have a check your understanding so that you can practice this on your own.